So here the question says the time it took a random sample of runners to complete a race are summarized in the table. First of all, take a look at the table. First thing to spot is that you got 29, 20 to 29, and then it goes from 30 to 39. So I can see at some point I will need a continuity correction needed. I'll just make a note of that. Continuity correction needed at some point. And if you write that down, needed at some point, that way you will make sure that you don't forget that. So always look out for that right at the beginning when I looked at any group data. Part A says use interpolation to estimate the interquartile range. So the interquartile range requires us to find out what the upper quartile is and what the lower quartile is and its actual position. So this means we would have to go and look at, I'll set that up and I'll work out my lower quartile position here. I'll work out my upper quartile position here. Okay. And then I'll be able to work out what my interquartile range is. Now, first of all, we need to know how many runners we have in total. So we've got 5, add the 10, which is 15, 15 add 36, add 29, and that gives us a total of 80. I'll just make a note of that, 80 here. So the total is 80. So the lower quartile position is the 20th position. Now I can see here, if I look at the cumulative frequencies, I've got 5 there. 5 add 10 is 15. And then I've got 15 add the 36, 51. So the 20th runner, i.e. the lower quartile position, the 25% position, is in the group from 40 to 49. But remember, I needed my continuity correction. So I'll go and write down here 39.5 and 49.5. And I'll write down what my cumulative frequency is for the lower quartile. At the 39.5 mark, it's 15. And at the 49.5 mark, it's 51. I want to work out what the 20th position is. So I'll write down the 20th position there in the cumulative frequency row. And above was my time, my actual data, and I want to work out what X is. Likewise, I will then need to find out my upper quartile position as well. Okay. So the upper quartile position would be the 75th percent of 80. So 75th percent of 80 is 60. So I'm looking at position 60. Now position 60, if I look at my cumulative frequency, is in the group 50 to 59. So again, continuity correction needed here. So I'm going to go from 49.5 all the way up to 59.5. My cumulative frequency up to 49.5 is 51 and 71 here. I'll just make a note. This is my cumulative frequency and this is my time. And what I'm after is I'm after the 60th position, and I'll call that, I'll call the first one X1 and I'll call this one X2. So again, by setting up my interpolation, remember it's this over that divided by this over that. So that will be X1 minus 39.5 over 49.5 minus 39.5 is equal to 20 minus 15 over 51 minus 15. And from there, I can work out X1. And my X1 comes out to be 40.9 here. I can do a similar calculation for the upper quartile, and I'll work out what my X2 is here. I'll write that down. I'll just go and write the answer down, but it's exactly the same kind of way we approach that. And my upper quartile comes out to be 54 here. And so my interquartile range, which I'll write down for part A, they're asking me to work out. Interquartile range is upper quartile minus the lower quartile, and so that's 54 minus 40.9. So my interquartile range here is 13.1. Okay, so that's part A, using linear interpolation. Then it goes on to saying, well, the midpoint of each class was represented by X and its corresponding frequency given by F. And then it tells us the sum of Fx and the sum of fx squared. And what it's asking us to do now is to work out an estimate, the variance and standard deviation for this data. So let's take a look at how we would approach this. So part B. First of all, let's write down my formula for the standard deviation for grouped data. So standard deviation, which is sigma, is equal to the square root of, remember what it is, it's the mean of the squares, so that's sum of fx squared over sum of f minus the square of the mean. So the mean is sum of fx over sum of f, and it's the square of the mean. So that's what I would write down. That's not given to us in a formula book. We need to know that. We can maybe deduce it from one of the formulas given in the formula book, but you need to understand it's the mean of the squares minus the square of the mean. Square rooted gives us the standard deviation. So let's go and take a look at if we can work this out then. Well, we know what the sum of f is. We've worked it out. Sum of f is 80. Sum of 80 is the total frequency. So what's the sum of fx squared? Well, the sum of fx squared they've given to us here. So sum of fx squared is 1,83040 divided by the sum of f, which we know is 80, minus the sum of fx, which again they've given to us here, 3740, divided by the sum of f, which we know is 80, all squared here and then square rooted. So that's essentially what we're doing. Now, if we then go and do that, we can get our answer for this. That will give us the standard deviation, which is square root of 102. So we can then go and say what the standard deviation is. Standard deviation is equal to square root of that, which is 10.1 to 3 significant figures. And variance, which they also ask for, is, remember, the square of standard deviation, which is 102 before we square rooted it. So that's what they asked for. That's what our answer is.